everyone, my name is Alisha and I am a 10th grader from Advisory H. This video will be about my Term 2 project in Physics 1. So first things first, the big question for this term is why do visionary leaders adapt? And then we have the project focused question, which is how can human analyze transformation based on physics concept and law in a day-to-day life activities? There are a few outcomes which are related to this project. The first one is the third outcome, which is able to develop a forward-thinking design based on the understanding of Newton's law of motion. The second one is the fourth outcome, which is able to analyze a daily life problem based on the principle of work, energy, and power. This is photo 1, and as you can see, in photo 1, natural force and gravitational force are present. Fn, or natural force, is one of the contact forces, which prevents an object from falling through the surface of another body. It is always going upwards, as you can see from the yellow arrow. And then Fg, or gravitational force, which is attraction between objects due to their masses. It is always going downwards, as you can see from the red arrow. For photo 1, there is no friction because the item is being carried, and there is also no tension since the object isn't strained, it is being carried. The object is also experiencing unbalanced force since the object is at rest in my arms and it takes an unbalanced force for it to be in motion. For the Newton's law applied, there are 3 Newton's law which we learned. For the Newton's law applied in photo 1, there is the first law, which is the law of inertia, but it is inertia at rest since the object isn't in motion and is being carried. This is photo 2. The second photo isn't of me, but of Gabriel Aubrey and his daughter, which I will analyze. And as you can see in this photo, friction force and tension force are present. Friction force, or FF, is when the force exerted by a surface as an object moves across it or makes an effort to move across it. Here, the force of him pushing the swing makes the force push back the swing towards him again in attempt to stop, as you can see from the green arrow. And tension force, or FT, is defined as the force that is transmitted through a rope, string, or wire when pulled by forces acting from opposite sides. Though, on a swing, the rider or the tension in the chain and the weight of the rider. Here, the tension is between the daughter's weight and the chains of the swing, as you can see from the blue arrow. For photo 2, there is applied force, since he is pushing his daughter on the swing. He is exerting force towards the swing, which the swing returns when it swings back towards him. For the Newton's law applied, the second law is applied here, since the second law states that when a constant force acts on a massive body, it causes it to accelerate. Where here, he is pushing his daughter on the swing constantly, therefore the swing accelerates as time goes on. This is photo 3. This photo is a tug-of-war games during summer games. Here is an example of balance force. This is because one party is pulling towards themselves, and the other party is pulling it back, making it balance. There is also tension force present. Where the kids are pulling the rope back and forth, there is tension. For the Newton's law applied, in this picture, the third law is being applied, which states that for every action, there is an equal and opposite reaction. Here, the action is one part pulling, and the opposite reaction being the other party pulling back. Then we have the law of conservation of energy. This is photo 4. The fourth photo is another photo of Gabriel Aubrey and his daughter. We have PE, or potential energy, which is energy that is stored and is waiting to be used later. Here, the potential energy is when the daughter is hanging in the air. The unit for this is J, or joules. To find PE, you need to multiply mass times height times gravity, which with estimation would be 30 kilograms times 0.6 meters times 10 meters per second square, which would result in 180 joules. Then we have KE, or kinetic energy, which is energy an object has due to its motion. Here, the kinetic energy would be when its daughter falls back down to the ground. Kinetic energy has the same unit as potential energy. To find KE, you need to multiply 1/2 of mass times velocity square, which with estimation would be 1/2 parenthesis 30 kilograms times 1 meter per second square parenthesis equals to 15 joules. Lastly, there is TME, or total mechanical energy, is due to the position and motion of the object, other times referred to as ME. To find TME, you need to sum PE plus KE, which would be 180 joules plus 15 joules, resulting in 195 joules. Then we have the answer to the big question. Why do visionary leaders adapt? Well, because there are many different situations in which leaders will have to face, and in order to represent and lead their people well, then they must be ready and be flexible towards different types of situations given or comes their way. Then the answer to the project focus question, which is how can humans analyze transformation based on physics concept and law in a day-to-day life activities? Humans can analyze transformation based on physics concept and law in a day-to-day life activities by becoming more observant and keen in recognizing the different components that appear and are involved in our daily life. That is all for this video. Thank you for listening.